Hello, I'm Liam, part of engineering here at CloudCannon, and it's good to be back at HugoConf. Last year at HugoConf, we announced Pagefind, the open source search library that we built for static websites. Thanks to all the attendees and the wider Lean Web community, we had a great reception to this new entry in the search landscape. Since that release, we've been hard at work improving Pagefind, and I'm excited to share that last week we launched Pagefind's 1.0 release, which is a huge milestone for us in this project. Today, I'm here to talk through what we've built and learned in the past year, culminating in this stable 1.0 status for Pagefind. I'll also cover some future plans on the areas we want to improve further and directions we want to take Pagefind going forward. First, for those unfamiliar with Pagefind, it's time for a very quick demo. Our starting point is a fresh copy of the New Dynamics fantastic Ananke theme. For this demo, we're just going to add a search input on the homepage using Pagefind's default UI library. Following the documentation, our first step is to add Pagefind's assets and an element within which to place our search UI. For now, I'll just insert those onto the homepage layout. You'll notice that these reference URLs on your site. Pagefind will create these required files for you when it runs. With our search UI placed on the page, let's build our Hugo site. And now that we have our HTML files in our public directory, we're going to run Pagefind. Pagefind itself is a native binary, and you can download releases from GitHub. Alternatively, Pagefind distributes its binaries via an npm package that lets us run Pagefind without a separate install step. Using the latter, we'll run npx pagefind --site public. For most setups, this is all you'll need to configure, which is telling Pagefind where our static HTML files are. Running that command, we see that Pagefind indexed our site, and it has created the files we referenced earlier inside our public directory. With that, we're done, and we just need to host our static site. I'll use the built-in Python web server to help show that there isn't any magic going on here. And now we see in our browser a search on the homepage that's working. And that's time on the speedrun of Pagefind. We now have a fully functional search with room to customize if we need it. And most importantly, it's both fast and very low bandwidth. Filtering our network requests here, we can see that we initialize Pagefind and search for a phrase in under 100 kilobytes of bandwidth. This is a small site, so that isn't too exciting, but it becomes much more impressive as your site scales. For a more real-world example, let's check out godot.pagefind.app, which is Pagefind's sample index over Godot's substantially larger static documentation site. Here, I can search for shader and get results in 162 kilobytes over the network, including Pagefind's dependencies. These two aspects, extremely simple setup and the smallest bandwidth hit possible, are Pagefind's core tenets, and anything we build going forward must play within these rules. With that in mind, we're going to pick up where HugoConf left off last year, at Pagefind's 0.4.1 release, and quickly cover the big milestones since then. As we go, I'll touch on how these new features live up to the core tenets of Pagefind. One use case we needed to support early on was searching across sites. The CloudCannon marketing and documentation sites are separate Git repos with different build steps, which means they never exist on disk at the same time to index into Pagefind. To solve this, we built Pagefind a multi-site feature. This allows you to bridge indexes and domains at search time, loading more than one index in the browser and combining the search results. If you use the search on CloudCannon's marketing site, you'll see this in action, with results for blog posts and documentation interspersed. Looking back at our goals, on the setup front, this multi-site feature requires zero configuration at indexing time and is just one extra line when using a Pagefind library. For bandwidth, we'll need to take a look under the hood and get a refresher on Pagefind's index structure. This is what a simple Pagefind index looks like on disk. At the root level, we have Pagefind's core dependencies, then we have a folder of search index files, and finally a folder of result fragments. When you initialize Pagefind, these top-level files are loaded. When you run a search query, one or sometimes more index chunks are loaded to find the relevant data. And then finally, result fragments are loaded only when a search result actually comes into view. For multi-site, we can share almost all of the core dependencies, loading them from the site the visitor is searching from. Querying for data, we will need to double up on that index chunk as it loads, as we'll need to pull one from each site. Then finally, displaying results is effectively the same, since a fixed page of results will only load that many fragment files. On balance, multi-site tends to add around 30 to 40 kilobytes to the average Pagefind request. Importantly, this network cost is entirely opt-in. If you don't need to search across multiple sites, nothing changes. Another feature we needed almost immediately was support for multilingual websites. As a small segue into the wider world of CloudCannon's open source tooling, we use our translation app Rosie to build a lot of websites. And while the initial version of Pagefind could search these sites to some degree, we missed the special language handling for stemming words, and returning results across all languages wasn't particularly helpful. That need is what led to Pagefind's multilingual support. One of the lovely aspects of correctly formed HTML documents is that your HTML element should have a language attribute that describes the page. Since Pagefind ingests this HTML, we can read this attribute and split the processing into separate index chunks for each language. Looking at the configuration, we find nothing required again. Pagefind fully supports multilingual sites out of the box. In fact, pulling up our Ananke demo from earlier, if we swap over to the French version of the site, we'll find an already translated Pagefind UI. Searching here, we only see results for the French pages of the site, and we even have dedicated language support for matching root words with each other. On the networking front, multilingual actually helps reduce Pagefind's bandwidth usage. As it now only searches the language of the active page, we only need to search one subset of the index from any given page on the site. Additionally, Pagefind produces a dedicated WebAssembly file for each language on a site, which avoids loading language-specific algorithms that aren't required for the language you're searching. In between those big milestones, we were busy improving the default UI library, expanding platform support, and rounding out many smaller features and configuration options. An enormous thank you goes out to everyone who was involved in submitting issues and contributing some features and fixes along the way. So, with that, we've arrived at Pagefind's 1.0 milestone. This is something we started work on earlier this year, wrapping up the feedback and requests we heard the most from the community using Pagefind, both where it shined and where it needed to improve. On the good side, the biggest positive signal we constantly heard was that Pagefind was still super simple to set up and just works really well out of the box. And the biggest area we knew we needed to improve on was returning the best search results and getting closer to feature parity with some of the alternatives people wanted to migrate from. First, and largest on our list, was relevancy. Pagefind's initial goals were entirely around getting that network payload as small as possible, not necessarily having the smartest search algorithms. Now that we've firmly achieved that initial goal, we have the time and space to really level up the quality of the search itself, and 1.0 is a giant step in that direction. Feature number 1 for relevancy is content weighting. This is a new feature that allows you to tag elements in your HTML with a custom weight that will make the containing text more or less important when ranking your search results. In the eye of giving Pagefind the best out-of-the-box experience as possible, all H1 through 6 heading tags are weighted above your body text by default. This immediately gives a very strong preference for pages that contain your search query in their headings, which is a very good signal that the page is relevant. This new weighting feature also works great for deranking content. If you're indexing a technical documentation site and you find that code snippets are overrepresented in your search results, you can wrap your code blocks in a data Pagefind weight attribute with a score below 1, which will make the body text much more favorable for Pagefind to return. Feature number 2 for relevancy is better indexing for compound words and code. In Pagefind's 0.x releases, all punctuation was stripped when indexing. This would cause a word like data Pagefind body to be indexed simply as a single data Pagefind body word, preventing it from coming up when a user searches for body or Pagefind. With 1.0, this word will now be indexed as data Pagefind body still, but also data Pagefind and body all at the same location. This also works for changes in casing, so Pagefind UI will now return results for UI on its own. What's even better is that with the addition of Pagefind's weighting system, these compound words are automatically weighted below the word they make up. If the data Pagefind body word was within a code block tagged with a weight of 1.5, then data, Pagefind, and body would each be indexed at that location with a weight of 0.5. This helps keep whole words relevant while surfacing compound words where it makes sense. In sum, weighting in compound words had a very marginal impact on the index weight. And since we chunk the indexes based on a target file size, if anything, they cause a few more index chunks to be created, rather than an increase in total bandwidth. To help illustrate that, I've revived the MDN demo that I showed last year, but this year it's good enough to share. You can find this at mdn.pagefind.app. Loading this using a 0.x release of Pagefind, we can see that a search for SVG takes around 200 kilobytes of bandwidth to resolve. Now, on 1.0, with all of our new features, searching for SVG takes still around 200 kilobytes. These numbers do change based on how Pagefind splits up the index, but this shows that we're very much in the same ballpark for bandwidth usage. Next, in service of relevancy, are improvement to Pagefind's ranking calculations. These now integrate with weighting and compound words, and will also return partial results if there would otherwise be none, which gives us the start of some typo tolerance. Additionally, for ranking, Pagefind now takes how common the word is over the entire site into account. So a word will have very little impact on rankings if it's on every page of the site. When a user searches our MDN sample for the body element, we don't want to just surface the page with the most references to the, or even element, because we can tell ahead of time that body is the most unique word in this query, specifically for the site we're looking at. The best part of changing these ranking algorithms is that with the features built so far, the data was already there. Nothing needed to change apart from building and testing the code to make it happen. The final piece of the puzzle for surfacing relevant results was reworking the way Pagefind calculates excerpts to be smarter. This calculation now also takes weighting into account, so excerpts are more likely to include heading text than a code sample by default. All of this comes together to a release that greatly improved how relevant Pagefind search results feel. A demo is always worth 1,000 words, so we'll take a look at that MDN demo again. Here is a version indexed before the latest relevancy rework. Searching for SVG, we can see that the listing pages dominate these results due to the presence of methods containing the SVG term and the sheer number of results clumped together. Now we see the site indexed after the 1.0 release. With the same search term, we get substantially better results that prioritize headings and give us good excerpts. Looking at this page, you'll likely notice another new feature, and that's sub-results. This was probably the most heavily requested feature from users looking to migrate to Pagefind. Especially for documentation sites with long pages, being able to jump directly to the relevant section is vital to a great search experience. Another good example of this is Pagefind's own documentation. Previously, if you searched for root selector, you'd get a result for the configuration page as a whole. Now, with 1.0, you get a specific sub-result for each matching heading, and these jump you right to the relevant section. Keeping in tune with the theme so far, sub-results require no configuration when indexing your site. As it parses a page, Pagefind keeps track of all elements with ID attributes and surfaces these alongside each result fragment. Each of these anchors only needs to reference a location in the main content and its ID, so they don't add much bandwidth overhead. Additionally, they're stored in the very final result fragments, so only a few are ever loaded at a time. This data isn't needed while performing the actual search. Something we had requests for, but were less clear on how to support, was indexing non-HTML content. Pagefind is entirely structured around parsing HTML files into a search index, so until now, we haven't had any clear answer to this use case. With 1.0, we're releasing Pagefind's Node.js indexing API. This is an alternative to running the binary CLI, and instead takes the form of a library that can be imported to any Node script or program, and used to programmatically build your search index. At its simplest, you can import it and run it on a directory, and then write that directory to disk. This is functionally equivalent to running Pagefind's binary directly. Where this gets really interesting is by combining this step with custom data. The index exposes two other methods that are each interesting ways to index content. First, we can pipe in custom HTML. Perhaps we have HTML in memory that we want to index without first writing it to the file system. If that doesn't suit, we can skip HTML parsing altogether and add custom records directly to our index. This would allow you to build a script that parses PDFs or image metadata, JSON files, really anything that you could extract text from, and insert it into Pagefind's index. From there, you get all the benefits of Pagefind's front-end search performance on whatever dataset you have. This feature is very open-ended, so I'm particularly excited to hear from anyone who builds something interesting with this feature. Feel free to open a discussion on Pagefind's GitHub repo if you've had a play with it. And that's a wrap on the big headlines of 1.0. There are many more improvements and fixes included, so check the release notes on GitHub if you're interested in more. But before I go, I'd like to touch on what the future of Pagefind looks like. And a lot of that comes down to everyone listening. So much of this 1.0 release has been shaped by feedback from the community, so I encourage anyone with ideas to open issues on Pagefind's GitHub. If there's a way to build it while staying true to Pagefind's core values, it'll likely be picked up as a feature. In terms of roadmap that is known, the first big item on the list is to refine and release Pagefind's modular UI. This UI functions as building blocks rather than an entire unit, which allows you to construct your search UI out of modules that all talk to each other. This also means you can dip your toes into using Pagefind's underlying search APIs by, for example, using a set of official modules and also building a custom filtering or custom results module that better suits your site and your data. Additionally, we always have more we want to do on search relevancy and search performance for even larger websites. If you find cases where search results could be better, or sites where search isn't as snappy as you'd like, we always love to get new test cases through Pagefind's GitHub issues. That's everything from me for today. If you're interested in Pagefind, check out the website and documentation at pagefind.app. There, you'll also find our guide for migrating any existing sites to the 1.0 release. And as always, reach out if you have any questions, either through GitHub or feel free to find me on any social platforms and spin up a conversation there. Thanks.